Data structures in C#, a beginner's guide. Ever wondered how C# handles your data so efficiently? Let's dive into the must-know data structures in .NET. In the world of software development, data structures are the backbone of efficient and scalable applications. They provide organized ways to store and manage data, allowing us to perform operations quickly and effectively. Whether you're dealing with customer information, game characters, or complex algorithms, understanding data structures is crucial. In this video, we'll cover 5 key data structures in .NET C#: arrays, lists, dictionaries, stacks, and queues. We'll break down each one with clear explanations, practical examples, and real-world use cases. So if you're ready to level up your C# skills, let's get started. Let's kick things off with arrays, the most fundamental data structure in C#. Think of an array as a container with a fixed number of slots, each holding an element of the same data type. Imagine a row of numbered boxes, each box holding one item. That's your array. The beauty of arrays lies in their simplicity and speed. When you need to store a collection of related data, like a list of student grades or product prices, and you know the exact number of elements beforehand, arrays are your best bet. They offer lightning-fast access to elements using their index, which starts from 0 for the first element. Let's look at a quick example. Suppose you want to store the ages of 5 students. You can declare an integer array like this. This creates an array named ages that can hold 5 integers. Now, to assign values, you can directly access each element using its index and so on. To retrieve a value, simply use the index again. We'll display the age stored at index 2. However, the fixed size nature of arrays can be a limitation. Once you create an array with a certain size, you can't easily add or remove elements. If you need a more dynamic collection that can grow or shrink as needed, lists come to the rescue. But before we move on to lists, let's recap the key takeaways about arrays. They're simple, fast, and efficient for fixed-size collections. They provide direct access to elements using indexes, making them ideal for scenarios where you need to access elements quickly based on their position. However, their fixed size can be limiting if you need to add or remove elements frequently. In such cases, lists, which we'll cover in the next chapter, offer a more flexible solution. Welcome back. In the previous chapter, we learned about arrays and their efficiency in handling fixed-size collections. But what if you need a data structure that can grow or shrink dynamically as your program runs? That's where lists come in. Lists in C# are dynamic arrays, meaning they can adjust their size automatically as you add or remove elements. Think of a list as a stretchable container that expands or contracts based on your needs. Let's say you're building an application to manage a list of customers. You don't know beforehand how many customers you'll have, so using a fixed size array would be impractical. With a list, you can start with an empty list and easily add new customers as they sign up. Here's how you create a list to store customer names. This creates an empty list named customers that can hold strings. Adding elements to a list is a breeze. You can use the method. Now, your list has 2 customers. What if a customer cancels their subscription? No problem. You can easily remove elements from a list using the method. Now, your list only contains Alice. Lists offer several advantages over arrays. Their dynamic nature makes them ideal for scenarios where the number of elements is unknown or changes frequently. You don't need to worry about exceeding the array's capacity or manually resizing it. Moreover, lists provide a rich set of methods for adding, removing, searching, and sorting elements, making them incredibly versatile for various programming tasks. In the next chapter, we'll explore dictionaries, a powerful data structure that allows you to store and retrieve data using key-value pairs. Chapter 3: Dictionaries, your key to efficient lookups. Welcome back to our exploration of data structures in C#. So far we've covered arrays and lists, both excellent for storing collections of data. But what if you need to access elements not by their position, but by a unique identifier? That's where dictionaries shine. Imagine a phone book. You find a person's phone number using their name. Similarly, dictionaries in C# allow you to store data as key-value pairs, where each key is unique and associated with a specific value. Think of it as a collection of items with labels. Let's say you're building an application to manage student records. You could use a dictionary to store student IDs as keys and their corresponding names as values. This way, you can quickly retrieve a student's name by simply providing their ID. Here's how you create a dictionary to store student data. This creates an empty dictionary named students, where keys are integers representing student IDs and values are strings representing student names. To add student records, use the method. Now your dictionary has two entries. Retrieving a student's name is as simple as providing their ID as the key will display Alice. The real power of dictionaries lies in their efficiency. They use a technique called hashing to store and retrieve data quickly, making them ideal for scenarios where you need to perform frequent lookups based on a unique key. However, it's crucial to remember that each key in a dictionary must be unique. Attempting to add a duplicate key will result in an exception. In the next chapter, we'll dive into stacks, a data structure that follows the last in, first out principle, useful for managing function calls and undo operations. Chapter 4, Stacks, Mastering the Last in, First Out Principle. Welcome back to our journey through C# data structures. We've explored arrays, lists, and dictionaries, each offering unique ways to organize and manage data. Now, let's dive into a fascinating data structure that follows a specific order of operations, the stack. Imagine a stack of plates. You can only add a plate to the top and remove a plate from the top. This is the essence of the last in, first out, LIFO principle that stacks embody. The last element added to the stack is the first one to be removed. Stacks are incredibly useful in various scenarios. Think of the undo functionality in text editors. Each action is pushed onto a stack and clicking undo pops the last action, effectively reversing it. In programming, stacks are often used for managing function calls. When a function calls another function, the current function state is pushed onto the stack. Upon completing the called function, the previous state is popped, and execution resumes from where it left off. Let's see how to use stacks in C#. First, you'll need to create a stack object. This creates an empty stack named numberStack that can hold integers. To add an element to the stack, use the method. Now the stack contains two elements with 20 at the top. To remove and retrieve the top element, use the method will display 20, leaving 10 as the new top element. Stacks also provide a method to retrieve the top element without removing it, like taking a peek at the top plate without removing it from the stack. In the next chapter, we'll explore queues, another data structure with a specific order of operations, first in, first out, which is widely used in managing tasks and simulations. Chapter 5 Queues, Understanding the First in, First Out Principle. Welcome back. In the previous chapter, we delved into the world of stacks and their last in, first out nature. Now let's explore another fascinating data structure that follows a different order: queues embodying the first in, first out, FIFO principle. Imagine a queue of people waiting in line. The first person to join the queue is the first one to be served. Similarly, in a queue data structure, the first element added is the first one to be removed. Queues are incredibly versatile and find applications in various domains. Think of a printer queue. Documents are added to the queue as print jobs arrive, and the printer processes them in the order they were received. In programming, queues are commonly used for managing tasks, handling requests in a web server, or simulating real-world scenarios like customer service lines. Let's see how to work with queues in C#. First, you'll need to create a queue object. This creates an empty queue named task queue that can hold strings. To add an element to the rear of the queue, use the method. Now the queue contains two tasks, with task 1 at the front. To remove and retrieve the element at the front of the queue, use the method will display task 1, leaving task 2 at the front. Similar to stacks, queues also offer a method to retrieve the element at the front without removing it, like checking who's next in line without actually serving them. That wraps up our exploration of queues. We've now covered 5 fundamental data structures in C#: arrays, lists, dictionaries, stacks, and queues. Each data structure has its strengths and is suitable for specific scenarios. Choosing the right data structure for your program depends on the problem you're trying to solve and the operations you need to perform. Today we explored arrays, lists, dictionaries, stacks, and queues in .NET C#. Each serves specific purposes depending on your needs. From storing collections of data to managing function calls and simulating real-world scenarios, understanding these data structures is crucial for any aspiring C# developer. If you found this helpful, don't forget to like, subscribe, and hit the bell icon for more C# tutorials. Your support keeps this channel going and helps me create more content to empower you on your programming journey. Comment below which data structure you use the most and why. I love hearing about your experiences and how you apply these concepts in your projects. And hey, if you have any questions or suggestions for future videos, drop them in the comments too. In the next video, we'll dive into advanced collections like HashSets and linked lists.